Hi, my name is Anand Krishnamurthy. I'm a developer for the Open Enclave SDK. And in this session, we are going to take a detailed look at Azure Confidential Computing demo, where we show how to protect data when in use. In this session, we are going to take a look at how we can develop a pretty complex application. I have a customer with me that has some very interesting requirements. So let's hear from my customer, Pong Pong.
Hi, Anand. Hi, hello everyone. My name is Peng Wang. I'm the developer at Microsoft. I have this. I heard this ACC technology, which is very interesting, and I have this application in mind. I want to use ACC technology to enable it. This is diagram I have in mind for my application. As you can see, right, I want my application to have this protection or confidentiality to protect data in use, which fits very well for your description of the enclave support on OE SDK and Azure Confidential Computing VMs capability, etc. At the same time, I have this requirement on multiple clients want to send their data into this enclave for doing this aggregation, while these clients do not share data with each other. But besides this, I have this additional requirement. I want the end-to-end security. For instance, I want the client to be able to verify this is really an enclave, and some application I trust or the client trusts before sending the data over.
Got it.
It makes sense?
Yep. So to summarize, this is a multi-party computation application.
Yep.
Where each party's data ought to be protected from the other party, right?
Yep.
Oh, very interesting. Yep. And this
actually,
secure channels.
Sorry for interruption. Actually, I've got one more requirement.
Okay.
Actually, I want this to be a scalable application scenario.
Okay.
I want, for instance, right, I have multiple clients. I want them to be able to send data simultaneously to the enclave.
Sure. Okay.
I have
something
I have in mind with maybe a thread pool model that could be leveraged here.
Awesome. I think this is a very interesting application, and hopefully, let's get you started with how we can go about developing it. Are you ready?
Yeah, sounds good. Yeah, let's go.
Awesome. So let's go ahead. So first, let me just point you to how you can go about, setting up a VM so that you can do some prototyping. So I would suggest that you first visit this link where it tells you how to get started with Azure Confidential Computing. So here we talk about how to create a VM, configure your VM, install the OE SDK, and then finally to make sure that all the basic tests pass. So once you have reached that stage, you are pretty much all set to go, have fun developing your application. So at this point, I would recommend that you go take a look at the samples. And it just so turns out that we have samples for almost all of your requirements, that describe how to attest, an enclave remotely from any running application, and how to create multiple threads within the enclave, how to make it scalable, etc.
I see.
So let me know if you have any questions.
Yes, I do have a question.
Yep.
But my clients, they do not necessarily need to be, for instance, Intel SGX based VMs, right? They could be any VM on any public cloud or any on-premises machines. Do you have some samples to showcase that?
Yes, we do have a sample. So what we call this scenario is known as host verify. This means that the verification happens on a non-enclave, outside the enclave. So the host could be running anywhere. It could be running in an edge device. It could be running on your laptop, or it could be in some other cloud provider. It does not have to be SGX hardware. Would that work for you?
Yeah, that's actually great.
Awesome. So now, please feel free to ask any more questions. Just like, when you want to learn something, right, you always start off with the Hello World program. So I would recommend that you start off with the Hello World sample. It just shows you how to write a very basic application that just prints Hello World, but the printing happens from an enclave. If this works properly, you have right now written your first enclave. So after that, like you can see the complexity of the samples keep increasing. You deal with file encryption, then data sealing, then remote attestation, local attestation, and finally attested TLS. So you had mentioned that you want a secure channel to send data from your clients all the way to the computing engine. So what you would use is an attested TLS. So there's sample for this too. And then this is what we, to answer your very specific requirement, it's called host site enclave verification, where the entire verification engine is on a non-enclave, right? It could be your laptop or anywhere, any edge device. It could be your phone in theory. So, and then you send and verify data and establish a secure channel with an enclave that is running in the cloud, and you exchange information and perform multi-party computation. So did you want to take a look at any sample in particular?
I think I got the gist of what you are offering. I do have one more question regarding the multi-threading support, right? Do you have some
yes.
pointer to that?
So some of the samples do demonstrate multiple threads. For example, the switchless calls, which allows a very fast way to make enclave calls, shows multiple threads. But what I would recommend is this is an open source SDK, so you're free to download the source code, build it, have fun with it, extend it, contribute back. So you can just go to the Open Enclave SDK page here. So as you can see, it has third-party code. It has got enclave side infrastructure, host side infrastructure, samples. That was the one I showed you, as well as a whole bunch of tests. So the test logged down almost all features, and the one you are interested in is threading. And if you were to look at the code here, you would get some examples of how to launch multiple threads within an enclave and how to make your program more performant, more scalable.
Sounds great.
Awesome. So going back to the samples, so now that we are all set with how to run multiple threads from within an enclave, do you want to look at, say, the host verify sample? Because that seems to be one of your key requirements.
Yes, please.
OK. So the host verify sample, the key thing, this sample again locks down just the host verification part. We try to keep this sample as simple as possible. So if you were to look at the CMake, the SDK, mostly is built with CMake in mind, so it's portable. So the SDK has factored out all the verification into a separate library called host verify. So you can link this library into any application. You could link it to your C application, your C++ application, a .NET application, or pretty much, so long as you have the bindings, and then use the functions that is provided by this library to actually verify as a report, an identity that a remote enclave will give to you. Thus, you can attest it locally just using this library. So so far, so good. Does it make sense?
Yeah, that's very helpful, actually.
So, and this program, this example is quite simple. We intentionally made it, just do one thing, right? Demonstrate one thing. So in this program, all that is happening is that you have a report. A report is an identity of an enclave. So in this case, the enclave is running remotely in the virtual machine. And we say, hey, enclave, give me your identity. So the enclave sends a binary blob of data, and we call that report. And that report, we are attesting locally. And this is, keep in mind, this is not running on SGX hardware. It could be running on your laptop. That may not be SGX. It could be anywhere. And we just take this report and use the host verify library to perform an attestation of the enclave. If the attestation succeeds, you can be confident that the enclave is what it claims to be. If it fails, you should not trust that enclave. So this would be the first step in establishing a secure communication channel with a remote enclave. Do you have any questions?
I think this is great. I think I got what you were saying, and I think actually the sample looks pretty straightforward for me to follow.
Yep.
I think I'm ready to try it myself.
Awesome. So this is one thing I wanted, you to be, set up with. Try out the host verify sample. Then the next sample, you wanted a very secure channel, right? So it is not going to be as simple as this because you have to follow the TLS protocol to set up a very secure channel, right? So that sample is going to be a bit more involved than what you saw before. So in this attested TLS sample, but this is very interesting. So if you have played with this sample, and if you can incorporate pieces of this sample into your application, you pretty much have the capability to establish a secure channel between a host and an enclave that is running remotely, or it could be between two enclaves that are running on two different cloud platforms, and they can securely talk to each other.
Oh.
So in this case, you have a host and a server, and you establish a fully attested TLS channel. So what this means is that the channel is secure, and you also have hardware guarantees ensuring that the two endpoints are whom they claim to be. So the channel is attested. So it is very similar to the normal TLS channel, but with extra guarantees. Mm-hmm. So there's a nice overview here.
Yep, sounds good. I think yeah, thanks for all the help. I think with all the samples, I should be able to, as I said, get started and leverage both OESDK and as well as the Azure Confidential Computing VM to start my application.
Awesome, that's good to know. So with this, let's go now take a look at a demo.
Multiple party computation demo, and this demo is made only, or this application is only made possible through ACC technology, where multiple clients can send data to the same platform, which is protected. Confidentiality is protected by the enclave. Now the server is enclave where the three clients can send data over. But the important piece here, though, is even though the enclave is protecting data in use, we need to make sure the end-to-end security is there. This is guaranteed by the secure channel, secure communication channel between the enclave, the server here, with all the three clients. So I'll show the demo how this is working. Now I can start the server. As you can see, the server started and it's listening 3 dedicated ports for the secure connection or attested TLS connection to it. All right, now let's start one of the clients. This client is actually from AWS. And the client is start initiating the handshake, TLS handshake. And as you can see, the regular TLS handshake is happening. Inside the certificate sent from the server, which is the enclave, there's also a embedded code. The code has 2 purposes. One is it verifies this is actually an enclave application. Also, during the code or inside the code, there's some additional information about the application running inside the enclave. For instance, there is a unique ID, which is a hash of the application binary, and there is a product ID for the application. And also we know for this application, what is the security version of it. And who the signer ID is where or who signs a application. And client has this opportunity during this attestation phase to identify all these important properties of the application and verifies whether these are indicating this is trustworthy application inside the enclave. If everything succeeds, it can start proceed with this TLS connection and then send data. Otherwise, it will just stop the TLS handshake and stop the communication. Now client is able to send data, and as you can see, 10 records are sent from this client, and server actually recognizing and saying, I got 10 records. Now let's say the second client. Second client is a Google Cloud Platform client. Again, it's trying to establish this attested TLS connection with the server. And during the TLS handshake, again, it got the embedded code about the enclave information, application inside enclave information as embedded code, as in the embedded code, and verifies all this application specific properties, satisfies his requirement on making or being a trustworthy server, and then proceed with the handshake and started or ready to be sending the data. Now data is sent, and you can see there are 9 records sent, and server acknowledged 9 records obtained. The third one is an interesting client, which is actually not any public cloud. It's actually my desktop. It's an on-premise client. Again, TLS handshake is initiated, and client got the certificate. Included in the certificate, there is this embedded code, including enclave application information, where he is attested and verified. And then ready to send data, and data is sent, and you can see 5 records were sent, and server side recognized and basically saying I got 5 records. Also on the server side, because he has a capability of getting all this data from different clients, and the clients are not sharing their data, so it's able to do an aggregation of all these records. They aggregate 10 records here, 9 records here, and 5 records here. Wait, why the aggregation is 10 plus 9 plus 5 to be 25? It should be 24. I think I have a bug in my application. I'll let my developer team know, and he can sort of help debugging and try to find what the issue. Yeah, I'll talk with him and sort of hand it over for him to investigate.
So in this, now that Peng has noticed a possible bug with the server, let's see how we can debug a server that is running an enclave via Visual Studio Code. Keep in mind that the server is running in an Azure VM. So I have here an instance of Visual Studio Code open on my laptop. So I have a few extensions installed that will help me debug an enclave that is running remotely. The most important extension I have is the remote development extension. This allows me to connect to a remote Azure VM and debug any application. And in this case, we are going to debug an enclave. So let me enable just-in-time access for it. While that is going on, let me connect first to the remote machine. So I click bring up the palette. I say click connect to a remote connect to host. And I choose the host. As you can see, I can have multiple hosts. The one I'm interested in is this one, 40. So you can see here that Visual Studio Code was able to connect to the remote host. Now we will from now on interact with this instance of Visual Studio Code. Let us open the source folder of our application. It is MPC demo, and we open it. So bear in mind that the files exist on the remote machine. Visual Studio Code is rendering those files locally. And this comes with the full suite of an IDE-like experience. First, let's look at the extensions I have installed on my remote machine. Visual Studio Code automatically takes care of this, installing the right extensions. So here, in addition to the remote extension, we have the C, C++ IntelliSense debugging and code browsing extension. This allows us to put breakpoints in applications and start debugging. So let's first go over how our application looks like. Based on the demo we saw, it had a host, which is the server, and it creates a front-end enclave and a back-end enclave. The front-end enclave is written in C++, and likely the bug is somewhere here. But let's first rerun the server and then send a request and see if we can debug it and identify the problem. So in order to debug an application, I click here, and there are two configurations. Either I can attach to an existing server application or launch a new instance. And I'm going to launch a new instance. And then I click run. So as you can see, now we are stopped at the main function of the program. I'll continue execution. At this point, you can see that the enclave is waiting for connection requests. So I'll ask my colleague to send a request again so that we can start debugging. So I had put a breakpoint in frontend.cpp, which is the code for the enclave, and that breakpoint was hit. So you can see there is, I knew I had a hunch that something about the count was wrong. And after the payload has been processed, you can see that the actual count is 10. We are going to add it to run count, which is already 1. I would kind of expect it to be 0 to start out with. In this case, I can look at the definition and kind of spot the bug. You can see that the count ought to have been initialized to 0, whereas it's initialized to 1. So that could be the reason for the bug. However, I can continue stepping through, note that down, step through, and debug it just like any other application. So in this case, the computation has finished, and we increase this count, and then we continue execution. So if we were to send, in order to debug further, let me just put a breakpoint here. And could my colleague send another request, please? So you can see you can debug a live system. I could very well have attached to an existing running server. In this case, we launched it. So you can see more context as to, and you can check whether all the parameters are correct or not about the request. This almost, keep in mind that this code is executing within an enclave. So a normal debugger will not be able to debug an enclave. We have enhanced the debugger to be able to debug enclaves. And another interesting thing to look at is the stack, call stack. So you can see that this is in the host side. A thread has been started, and the host side calls an enclave function. And at this point, it has entered the enclave. And so at this point is the transition from the host to the enclave that you can see on the call stack. And all this code that is above it are actually on the enclave side. So you get a full IDE-like experience. And there are many stack frames because there are multiple threads here. So this provides for a pretty much a complete debugging experience. So you can continue back, debug. And if you need to call any GDB function directly, you can say so you can interact with GDB natively via the debug console. So now that I have figured out that, hey, a possible cause for the bug is that the count was not initialized properly, I can continue debugging, or in fact, I can edit the code, fix it, rebuild it, and then retest it. Now, keep in mind that we get pretty much full IntelliSense both on the host side as well as on the enclave side via VS Code and the appropriate extensions. So now that we have finished debugging, shown how we can remotely develop and debug enclaves on Azure VMs, let me hand back the mic to my colleague.
Dan, just heard good news. You found a bug. I think with this extraordinary debugging experiences, we should be able to sort of do very efficient development and debugging so that we can ship the fix of the bug very quickly and ask our colleague to ship this amazing product to production very soon.